Today, I was going to cover the regression channel solvers there. These are two very simple solvers. Let's see here. Yeah, so on the list of solvers, yeah, we have the two regression channel ones here. So these are pretty simple. Obviously, it's going to be helpful to have a regression channel on my chart. And the one I'm going to use is from Lizard Trader. And there we go. Regression channel. And let's see here. 50. And I'm going to knock this out to 4. Because that'll help spread the channel out a little wider. So it makes it a little easier to kind of see what the solvers is doing here. Line the channels. Actually, I think I just want the channels. Let's see how that looks. Okay. Yeah, that looks good. Let's see what the lines look like. I haven't used this oh, okay. Yeah, let's turn on the midline there. That'll be helpful. Yeah, I guess just for reference here, looks like I am still using the original version of this. Oh, and the reason why I'm using the Lizard indicators one is when you scroll backwards on your chart, you can see the channel actually updates itself based on the historical data, which as far as I still know, the NinjaTrader one doesn't do that. So actually most charting platforms don't have a regression channel that shows correctly historically. So let's get a regression channel on here. All right, so this is the regression channel position. Let's connect that up. And I am going to copy the solver name, and I'm going to change the logic template name. There you go. So there we go. Change the name up there. All right, so just a little tip there. If you click on the result node, it's going to show you the name of the logic template up there. So this is another way that you can change the logic template name. So, the other way is to right click on it and there's a rename right there as well. So, all right, so back to the regression channel here. Now, to understand what this is doing here, it helps to look at a graphic here. So, it's one thing to have the regression channel on your chart, right? But to understand what these zones are, right? So we have zone A through zone F. We really need the graphic here. Let me pull up the documentation here. All right. So I am on the regression channel position solver there. And on the left menu, right, under the list of solvers there it is. Yep. And so on this page, if we scroll down past all the documentation and down to the examples here, there are a couple of screenshots here. Right? So let's see. Again, I'm on example 1A. And if we click on that image, that screenshot there, this shows you where the zones are in relationship to the regression channel. Right? So for a long output, so this is important for a long output, zone A is on the top, zone F is on the bottom, right, or above the regression channel, and zone F is below the regression channel, right? And we can see inside the channel there's 4 other zones there, right? So that's for the long output, right? So remember, zone A is on top. Now the other image here, right? This is for the short output, and we can see zone A is now on the bottom. And so as the image is illustrating, when price gets close to the bottom of the channel, or zone A, that is when we get a short output here. And vice versa. So when price gets up close to the top, which for a long output is zone A, right? That's when we're getting a long output. It was when price gets up to zone A for a long output. All right, so again, here's the long output, and we can see when price gets up here close to zone A or B, we're getting a long output here. Now, of course, when this solver gives you a long or short output, of course, depends on which zones are turned on, so to speak. All right, so let's go back to the solver there. Now, we can see the default output settings here. This is one of the solvers that still gives you a fuzzy logic output by default, right? So we can actually see here how, let's see, let's scroll back. Where are we? There. All right. So we can see basically the closing price of the bar is near, let's see, near, what is that? Zone E, right? So we can see zone E is set to 1, and zone F is set to 1, right? So these closing prices are within zone E. So if we go back to the image here, right, for a long output, zone E is inside, but we can see it's the lower quarter of the zone. And then, of course, zone F is on the outside, right? So this image actually is, hopefully you guys can see that compared to my chart, let's move this over, right? My chart compared to this screenshot here, we're actually getting an output in the opposite position of the channel, right? So, so the solver I have set up right now, we're getting along when price is at the bottom of the channel, whereas in this screenshot, we're getting along when price is, or the closing price is near the top of the channel, right? So this screenshot is basically giving us a long and a short output with the trend, right? Whereas the default settings here, so again, these are the default settings, we're getting an output that is counter trend. So think of it like a bounce. So for a possible bounce off of the channel, right? So we can see here, right, price bounced off of the upper channel, and we got a short output there. Actually, let's kind of zoom back here a little bit. Right, there you go. So that's a more accurate look at where price was. All right, so there we go. Price is coming up and approaching the upper channel there. Right, so basically for the short outputs, where price is at is zone E. So that's why we're getting a signal output or a value of 1. Right. So again, for the short outputs. So if we go back to the images here, right, for a short output, zone E is inside the channel but at the top quarter, right? And then as we step forward, now price has come down to zone E for a long output, right? So in other words, the lower quarter inside the channel there. And so that would be for the long output. There we go, zone E, right? So we can see the closing price is within zone E now. All right. So, again, this is, a counter trend output. So that's the default there. There you go. So that's the default outputs, right? So what the image was set up for is like this. And like so. All right, so A and B are set to 1 there, right? So now once price is near the upper portion of the channel, now we're getting a long output, right? Just like this screenshot shows. So that's it, really, in a nutshell. That's really what the regression channel position solver is all about. Is it just identifies the position at which the closing price of the bar is within. So obviously, this solver is very specific to just using the regression channel only. So, and of course, you can adjust the period of the channel and the width of the channel. So yeah, that's right. So the default is set to 4. So if you remember when I was setting up the indicator, I did set the standard deviation multiplier, or most indicators will call that the width there. And that's it. Real simple. So this is a pretty simple solver to use and hopefully to understand there. Right. So once you understand, where the zones lie, for the long and the short output, then setting it up, it will be pretty straightforward there. All right, so I will move on to the next regression channel solver here. And let's see here. All right, so next one, the regression channel width. So the regression channel width is basically a measurement of volatility here. So if you are using the regression channel to trend trade, then verifying the width of the channel, means that there's enough volatility, right? So yeah, if you are channel trading, then there's a good chance you're going to want a minimum amount of volatility within the market. So that's what this will measure here. Yeah, there's really no images are needed to illustrate this. It's just a simple measurement of the width of that channel. So I remember back in the day, I believe there was a regression channel indicator that would plot the width of that channel, so you could see the width on the chart there. If there was an indicator called regression channel width, really all it's doing is, now if we look at the properties for the regression channel, Harry, the guy who created lizard indicators, most charting platforms will call this setting here the width, but technically it's actually the standard deviation formula. So if you want to know what the width of your channel is, then you just pull up the standard deviation indicator, right, and then match up the period, and then whatever the standard deviation value is, well, that's what the width of your channel is, I believe. You might have to take the standard deviation, multiply it by 2 to get the width of the channel. Yeah, it's been a long time since I've looked into the code and actually checked out what the formulas are, but we know that the width of the regression channel is some factor of the standard deviation indicator, right? So and again, standard deviation is similar to the ATR indicator, right, giving you a measurement of volatility. Oh, let's see here. All right, so let's make a new logic template. There we go. And let's put the regression channel width solver on here. And let's name that logic template like so. There we go. And all right, so and let's see. Oh, yeah. So if you do get this error like this, just simply just reload the chart. All right, so the width here may look a little more complicated, but but we'll break it down here, make it real simple. So, and again, this output also is still designed to give you a fuzzy logic output by default here, right? So we can see that the way this is set up right now is the minimum width that we need to get an output here is 4 ATRs, right? So the measurement from the top of the channel to the bottom of the channels, that distance needs to be a minimum of 4 ATRs. And then you start to get an output. And the ideal width that's being looked for is 6 ATRs. Right, and let's see if I can scroll back to a period where things are really flat. Yeah, here we go. All right, so here things are really, really flat. Right, so this is going to be, right, the overnight session here. Yeah, so if we shrink this up, right, yeah, I mean, you can see there's not a lot of movement there. So the channel width is, let's go back a little bit further. There. So that channel width is less than 4 ATRs. And as soon as we step forward one bar, right, now the closing price made a little bit further, and that just barely has a channel width of more than 4 ATRs. Right, if we look at BloodHound's output, we can see it's 0.115. Right, so in other words, 11%. Right, so what that's telling us is that the minimum width of 4 ATRs for this channel has been met. So this channel is probably 4.2, if I'm doing the math right in my head. Yeah, I think the channel width is 4.2 ATRs, right, approximately. So, right. And then if we step forward again, so, and now the value increases to 0.15. So I believe that means the channel width is now 4.3 ATRs in width there. All right. So, again, the point is you'll start to get an output here at this minimum width. So we need a minimum of 4 ATRs before you get some kind of an output here. And then ideally you want 6 ATRs, right? So you'll start getting signals at just below 6 ATRs. So the ideal width isn't necessarily when you're going to get a signal. Because remember, and that kind of goes back to the fuzzy logic component here, right? So remember, these lines here identify when do you get a signal. And you get a racing stripe, right? So you get a signal at 80% of an output, or 0.8. Right? So now we're going to have to go back even a little further, take another step back here to understand what I just said. And that kind of goes back to the properties here for BloodHound. And most people probably don't pay attention to this. But again, this is part of the fuzzy logic here of BloodHound's output. So, right, so you get a racing stripe at 0.8. Right, so 80% confidence is when you get a racing stripe. So what that translates how that translates back to, you know, a solver that is still giving you an output in fuzzy logic terms. That means that once the channel width gets 80% the distance from 4 ATRs to 6 ATRs, right? So I think that's going to be 5.6 ATRs. Yeah. So I believe once the channel width gets to 5.6 ATRs, that's 80% the distance between 4 ATRs and 6 ATRs. Right. Yeah, and so that's when you'll get a signal, because the output has hit this little green line or red line here, right? So that green line or red line, you know, this isn't a part of the regression channel. This is a core part of BloodHound signaling. So those green and red line are showing you the 80% value, you know, that the output needs to get to, and then you get a racing stripe or a signal. So let's see, let's scroll forward here. Oh yeah, there we go. Yeah, so let me lock the scaling here. So yeah, so here the channel is starting to widen out, and let's move that up a little bit. All right, so as I step forward, you know, we can see the channel is widening out just a little bit more, a little bit more. There we go. So that one was a pretty big jump, right? So if we look at that width and then look at the next width, right? And we can see that the output is almost at that 80%. It's actually at 0.74. So 74%. It's almost there. And then the next one, well, actually now we have a value of 100%, right? So that means, right, with a value of 1, that's telling us that the regression channel is at 6 ATRs or greater of a width there. So, all right. Now, most people don't like using the fuzzy logic, right? It's a little obscure. So if you want to get rid of the fuzzy logic, all you got to do is make the ideal width and the minimum width match exactly. All right, and there you go. So, oh, and hold on. It changed it to ticks on me. Let's put it back to ATRs. There we go. If you are using ATRs, you can see that when you have ATRs selected as the measurement unit, that you can put the ATR value in there as well. So probably it would be good to match whatever your regression channel period is there, like so. And yeah, that actually makes a pretty significant difference there. But anyways, back to the point being made here, right, which is if you want to remove the fuzzy logic, just have the minimum width match the ideal width there. So now let's kind of scroll forward. There we go. Yeah. There. And actually, yeah, let me turn on the auto scale right there. There we go. All right. There we go. Now we can see the entire channel width there. So, yeah. Let's see. So as the morning trading picks up there, yeah, we can see that basically there's, well, interesting actually. That was pre-market trading, and then actually once the market opens, yeah, there's this brief period of a little consolidation, right? And then we can see the market kind of takes off to the downside, and now there's enough volatility, so there's actually 6 ATRs of channel width here between those two. So the practical, or I should say one practical use for this channel width, is possibly combined with the channel position. So if you are a regression channel trader, you're probably going to want a minimum amount of volatility, to trade within. So I guess again, this is probably a good example here where the market is kind of consolidating a little bit, right? Not a lot of movement. So some traders may not want to trade with that small amount of volatility. Let's see what else. So okay, let's cover the measurement units here, and these are universal across several solvers here. So the measurement units you have is you can check to see if the channel has a minimum width in points. And let's see, what are we on? I'm on the NQ. Yeah, so that channel's pretty wide. Let's go with 60 points. And yeah, there we go. So yeah, I mean, it's too hard to tell, but essentially, whenever we get to these bars here, right, the channel width is less than 60 points in width there. And there we go. Now that channel is at least 60 points wide or more. So there you go. So you can decide, what type of measurement unit you want to use for checking that channel width there. So points, ticks, Renko bricks, and ATRs. So, and I'll put it back to ATRs. All right, so I'm back on yesterday's data here, just taking a look. Yeah, not a lot of volatility yesterday, but let's go make an example here of combining these two regression channel solvers here. There. All right, so let's drag this solver over. So this is our regression channel position. And here's our regression channel. Oops. I had the wrong thing selected. There we go. I wanted to change the logic template, not the solver's name. And also, another little tip here, it's probably a good idea to actually kind of put in, the values there that you're using. All right. So this regression channel width is set to 6 ATRs. Okay. So if we now grab a AND node here, we can combine these. And let's see what happens here. And let's see here. All right. So actually, I still have the regression channel position set to right. I have zone A and zone B turned on. So this is giving me a signal kind of with the trend. but actually I think what most traders were looking at kind of back in the day when the regression channel was popular for a little while was counter trend signals like this there. All right, so with zone E and F, maybe actually let's go extreme here, and all right, so I made a copy of the regression channel position here, and I'm going to adjust the name here. There. All right, so this regression channel position, I'm only going to turn on zone F, right? So that means that the close is outside the channel. There. Let's plug that in. There we go. All right, so let's see what we get, right? So we get a buy, and price goes a little bit lower outside the channel, another buy, still outside, another buy, and there we go. And then price eventually bounces off that lower channel. And there we go. Price breaks out the top of the channel, so now we get a sell signal. Right there. And price does pull back to the mean. Let's see if we get another sell here. And I think now, okay, yeah. So we can see that the close is outside the channel. So how come we don't have a buy signal, a long signal? Well, that's probably because of the width, right? If we look at the width, yeah, see right here, basically as price has been moving up, the volatility has been getting smaller and smaller, so our channel was too narrow, and it's still too narrow here. And now if we step forward one more bar, there we go. Price went just a little bit lower, and now the channel width is wide enough there, right? It meets our 6 ATRs. And so now we actually get a long signal there. And now, yeah, I mean, we can really see that the channel has gotten really narrow now. So, yeah, I don't think there's any more signals. And I guess while I'm at it here, let me introduce my little tip here, right? So obviously the key, to this example working is the channel width, right? We need this 6 ATRs of channel width. So how do we know if our channel is wide enough here, right? Because all we're seeing is just, the trade signals. So what we can do is we can add an OR node, plug this into the OR node, and we can, if we go to the options tab here for the OR node, right? So I have the OR node selected. Go to the options tab, and I can adjust the output here. I can reduce the output, and I kind of like it somewhere around 0.2, 0.1, 0.2, whatever you kind of like there, and I'll this will be apparent here in just a moment. Well, actually, let's take a look at this first, right? And oh, hold on, let me put that back there. All right, and then if we add another OR node, combine that in, let's put 0.2 in there again. There we go. There. All right. So this is what I was wanting. So you see that small little output, right? That's 0.2. So that tells us when the channel is wide enough now, which means we could possibly get a signal once the channel is wide enough there. So once we see this output here, this little tiny output there, like so. Okay. So now, yeah, now that I see this little output here, all right, then if price gets all the way up to the upper part of the channel, then we'll get a short signal. Let's see if that actually happens. Oh, almost. There we go. Now price finally gets high enough. Right, so this little trick here that I do every once in a while, right, where if one of your solvers is kind of like a key filtering mechanism or a key filtering condition, right? So you know, filtering in this case would be we need a minimum of 6 ATR channel width before we can get a signal, right? So this solver here, right, the regression channel position, will give us all kinds of signals, but we're filtering these, these channel position signals. We're filtering them with a minimum channel width. Right? And so we can feed this key filter into an OR node, right, and reduce the output of that OR node down to something around 0.2, whatever you like to see, and then feed that into another OR node, along with the AND node that has your signals, right? So yeah, there. We'll just give that a name, right? So this AND node basically is giving us the signals there. And then you just feed the two logic nodes into another OR node, and then we get the combined result, which is we get the signals, and we can see when the regression channel width solver is telling us that the width is 6 ATRs or more. All right, well, I think that should do it for both of the regression channel solvers for today. Yeah, just to reiterate and clarify again, guys, this is not a trade room. So obviously anything you see in here is not a trading recommendation. So as we can see in today's market, where it's a serious down day today, trying to trade counter trend signals on the regression channel is probably going to be a big losing day. So yeah, we can see all these long signals here, and the market really did not bounce high enough to ink out any profits, at least not from these signals here. Surprisingly it did here. There was one thing here that I meant to mention. So back when I was covering the regression channel width solver here, I was going to show where, so if you, for some reason, if you need kind of further information on the different type of measurement units here, points, ticks, ATRs, Renko bricks, there is documentation on these. So these 4 measurement units are common amongst all the solvers that utilize a measurement unit there. All right, so you can find that by, let's see, if we go, well, actually, let me do it from within the BloodHound interface here. So let's see, if we go to the main tab, there we go. So on the main tab, there's the help menu, and we can pull up documentation there. All right, so that'll take you to the getting started guide here with a bunch of quick videos, but where we want to go for the measurement units is go to the BloodHound menu on the left and then click on the Confidence Solvers, right, page there. So this is a page here that just kind of describes in general what the confidence solvers are, and it also lists all the different properties that the solvers have in common. So yeah, so there's just a list of all the solvers here, and if we keep scrolling down, right, so it does explain, right, so the different data type inputs, right? So some of those inputs, I'm sure you guys have all seen. There's a fixed value, right? There's price, so you can put the closing price, right, as an input. The high or low is an input. Volume, indicator value, right? All the different data type inputs. And let's see if we keep scrolling down. All right, so here we go. So setting a distance. So down here, right? So this explains what points are, which I'm sure everybody knows: ticks, Ranko bricks, and ATRs, right? So there you go. So there's an explanation of all those measurement unit type of inputs. This information is on the Confidence Solvers page here.